So in the case of unequal time, so how to solve the average speed? This is most important. If you understand this model, we'll go to the next acceleration. After that, we'll go to the kinematic equations. Up to that, we'll cover for you. So here, a vehicle covers the total distance with the speeds v1, v2 in two equal parts. That means total distance is s. In that, half of the distance with the speed v1, another half of the distance with the speed v2. When the vehicle is covering total distance with the speeds v1, v2, first half is v1, second half is v2, but time is not given. So here you need to understand the time. This is happening in the equal time or unequal time?
Unequal.
Yes, unequal time. How to identify the unequal time? Because distance, same distance, different speeds means time will be different. So that is the thing you have to understand while solving the problem. If you understand that one, you can do it faster. Otherwise, you will get confused regarding the formula before and this one. So basic formula for average speed is same. What is the basic formula for average speed? Average speed equal to total distance by total time. What is the total distance? S1, S2, two parts. Yes, S1 plus S2 by T1 plus T. First, we are solving this to convert into formula. Now, what is S1? Distance. Okay, distance is given half S1. Second distance also given half S by 2. So I can write this one as S by 2 plus S by 2. First part distance S by 2, second part distance also S by 2. So S1 is S by 2, S2 is S by 2 by T1. What is T1? Time taken for this. But in the question, time is not given, but we know that it is unequal time. So whatever the quantities which are not given, that you have to convert into given quantities. What is given? Speed is given, distance is given. Time can be replaced with speed and time, because speed is equal to distance by time. You know that. The time formula can be written as distance by speed.
Speed into.
No. Distance by speed. Yes or no? Take it. Speed is equal to distance by time. Time is equal to distance by speed. So now replace here. What is T1? T1 means S1 by V1. T2 means S2 by T. Like this you have to convert. Now write this formula. Okay, S by 2 plus S by 2, anyway you get S. So directly I can write as S by 2 plus S by 2. This is S by 2, this is S by 2. Totally becomes equal to S. Okay. Denominator S1, S2. What is S1 again? S by 2. What is S2 again? S by 2. Replace here. That means I can write this one as S by 2. Here also S by 2. This is also S by 2. I can take S by 2 common. Shall I take common?
Yes, sir.
Yes. If you take in common, what you are going to get? That is 1 by V1 plus 1 by V2 in the bracket. Now what I can cancel here? I can cancel this S and S. I can cancel. Then after the denominator 2 will becomes to the denominator according to mathematics. The denominator of denominator always becomes numerator. Okay. Next, in this case, the average is equal to, now I can write 2 will be goes to the denominator, and this formula will becomes 1 by V1 plus 1 by V2. This is the most important formula you have to remember in the case of a vehicle covering a particular distance in unequal times. If the total distance is covered in two parts, formula will becomes 2 by 1 by V1 plus 1 by V2. Suppose if the vehicle is covering the total distance in 3 parts. How many parts? 3 parts.
Three parts.
Yes, 3 parts. In the case of 3 parts, here the formula will becomes 3 by 1 by V1 plus 1 by V2 plus 1 by V3. This is the most important you have to understand. If the vehicle is covering the total distance in n parts, okay, n equal parts. In this case, 3 becomes n by 1 by V1 plus 1 by V2 plus so on 1 by Vn. The formula will becomes like this. This is the basic formula you have to do. And most of the cases for your level or any higher level, okay, CET levels, we can come across this formula and this formula. More than this, they won't go, okay, present. So we will also do the problems based on average speed in the case of a body covering the total distance in two parts, two equal parts or three equal parts, like that. Okay, so I am writing this formula into another form of okay, option I can write. So what way I am writing, just note it. The V average is equal to this formula I am writing here, two parts. This formula I can write it like this. In this denominator, 2 by 1 by V1 plus 1 by V2, denominator which is there, you take LCM. If you take an LCM, what you are going to get? That you are going to get V1 into V2, you will get LCM. So if you take an LCM for this one, here already V1 is there, 1 into remaining term is V2. Similarly, second term V2 is there. So V2, if you leave it, remaining is V1. V1 into 1 is V1. So if you solve this one, you are going to get 2 into the red mark one. This is V1 into V2. This goes to denominator. So what I can write the formula here, 2 into V1, V2 by remaining terms I am writing in order V1 plus V2, because V2 plus V1 is equal to V1 plus V2. So this is the formula for V average. What is the formula? 2 V1 V2 by V1 plus V2 in the case of body covers the total distance in two equal parts. If it is three equal parts, this is the formula for that. Note on the problem. A car is moving on a road with the speeds 18 km per hour and 36 km per hour. 36 km per hour in two equal parts. In two equal parts. Calculate the average speed in meter per second. Calculate the average speed in meter per second. What is given?
A
Average,
kilometers.
yes, average speed is equal to 18 km per hour, 36. Here two methods are there. If you are directly taking the value, you will get the answer in terms of kilometer per hour.
Then we can convert it into meters per
Meter per
second.
second, one method. Otherwise, here only these values you can convert into meter per second. These values here only you can convert into meter per second. Then you
And
can do it directly as average speed. You will get the answer in meter per second directly. Which method shall we follow? We'll convert each one.
yes, sir.
First one, this is speed V1. What is the speed V1? 18 km per hour. That 18 km per hour, if you are converting into meter per second, what we have to multiply? 5 by 8. Simply 18 get cancelled, that is equal to 5 meter per second. Similarly, V2, speed of this second part, that is 36 km per hour. You can convert into meter per second, that is 5 by 18. Multiply with 5 by 18. How many times? 2 times, that is equal to, okay, 10. Yes or no?
Yes, sir.
That is 10 meter per second.
By 2.
Okay, now you take the average. Average is equal to formula V1 plus.
V1 plus V2 by 2.
Correct? No,
Sir, V1 plus V2 by 2.
no.
Sir. Sorry. By time.
What is the formula?
V1 plus V2 by T1 plus T2.
V1 plus
T2.
formula is 2V1 V2 by V1 plus V2. Just do it. Why we are taking this formula?
Okay, unequal.
They given equal parts. Covering with equal parts means time will be different. Different time means what is the average speed formula? 2V1 V2 by V1 plus V2. While solving this one, this is 2 into, what is V1 value? 5. What is V2 value? 10 by V1 plus V2, that is 5 plus 10. So whenever you are solving the problem, keep it in mind, don't multiply the denominator completely, okay? This one don't multiply, keep it like that, okay? So that you can complete the calculation faster. 2 into 5 into 10 by 10 plus 5, this is 15. Now you can cancel it. How many times? 5 threes are. Okay, you can cancel it. Now it becomes 20 by 3. Okay, that is what is the answer in terms of meter per second. Yes or no?
Yes, sir.
That is meter per second. So average speed is equal to 20 by 3 meter per second. Like this, I have to solve. A car covers a total distance in 3 equal parts. Cast, write it, okay? A car covers a total distance in 3 equal parts. First, 1/3 of the distance. First, 1/3 of the distance with 18 km per hour. Second, 1/3 of the distance with 36 km per hour. And the last 1/3 of the distance with 72 km per hour. Calculate the average speed in this case. Total distance is covering with how many speeds?
3 speeds.
Okay. All the distances are same or different?
Same.
Same. Same means time is? Time is unequal. Unequal time means what is the formula? V average is equal to how many parts? 3 parts.
3,
V by
3,
1 by V1 plus 1 by
1 by
V2 plus
1 by
V2. This is the formula. Now apply the values in this. 3 by 1 by V1. What is V1 value? Can we convert it into meter per second first? So
Yes, sir.
whenever it is given kilometer per hour number of parts, you better to convert it into meter per second so that calculation will becomes little bit faster. So 18 kilometer per hour means how many meter per second? 5 meter per second. Already we done here, right?
Means 10 meters.
This is 36 kilometer per hour means 10 meter per second. Next this one,
For
20 meter per second. Take it. 18 fours are how much?
70.
72 into 5 by 18. 18 fours are 72. 4 into 5, 20. 20 meter per second. Right?
Yes, sir.
So 1 by V1 is 1 by 5 plus 1 by V2 is 1 by 10 plus 1 by V3 means 1 by 10. Now solve this one. What you are going to get? 3 by. So take LCM of this denominator one. This is take LCM of this. What the LCM will get? The LCM of this one is equal to, if you want to write, keep it like this, 5 into 10 into 20. Don't multiply. If you multiply, it takes long time. Okay?
Yes,
So
sir.
now, here 5. 5 is there means how much? Remaining 2. 10 into 20, that is 200. Plus, second, 10 is there. 10 is there means remaining 5 and 20. That is how much? 100. Plus, how much? 20. Third one is 20 means remaining 5 into 10. 5 into 10. That is 50. Next, V average is equal to. Now calculate it. This is 3 into this denominator will goes to the numerator. Yes or no? Denominator of denominator becomes numerator. That is 3 into 5 into 10 into 20 by denominator is already 200 plus 100 plus 50. How much? 350. But don't multiply the numerator always, so that calculation will becomes faster. Now this 0 I can cancel. This is 5 sevens, 5. Now 3 into 20, 60 by 7. Simply meter per second. This is the way you can compute the answer faster compared to other method. If you multiply all the values, it will take a long time to compute the value. If the answer is in terms of decimals, you can convert decimal in the last step, 60 by 7. Okay, 8
Okay,
points,
sir.
8 point something like that. You can end the answer with accuracy. Is it okay?
Yes, sir.
Average velocity. What is the average velocity? The same like speed. Okay, a car is covering the total displacement in some parts. It may be equal parts, it may be unequal parts. It may be same speed or different speeds. Here also same concept like speed. We are classifying the average speed average velocity calculation in terms of two parts, equal time, unequal. So whatever it is, equal time, unequal time, average speed is a vector quantity. So basing on the initial and final position, we are solving the problem. So vector means compulsory having magnitude and direction. This length gives the magnitude, this arrow mark gives the direction. Okay, so to solve this one, I am taking here in the case of okay, equal or unequal time, whatever it is. So first in the case of equal, okay, equal time. This is time t, this is time t. In this case, what is the average velocity? In the case of average velocity, this velocity is v1 if you say, this velocity v2 if you say, or this displacement is s1 if you say, this displacement s2 if you say. According to given, you have to write the formula. Average velocity is equal to, basic formula is total displacement, that is nothing but s1 plus s2 by total time, t1 plus t2. Understand? It is same like previous, but there is a small difference. Is that difference also you need to understand here. That's why I'm explaining this. So this is the starting point now. This is ending
Yes,
point,
sir.
right? Now, vector quantity always depends on initial point, final point only, because we are taking a straight line to initial to final. In between, we are not bothering, right? So vector is always straight line. We are always concentrating on initial point and final point. Between that, we are taking the straight line. Based on the straight line, we explain. So here, this is the distance initially. Initial distance is 0. This is the final position. The final displacement is, sorry, not distance, displacement. Initial displacement is 0. Final displacement is, I am taking as s. Initial time. The initial time is 0 and the final time is equal to nothing but t. Now here, look at this one. This is important. This is the total displacement. Yes or no? The total displacement means this is the total from here to here. Yes or no? Red mark. Here to here is the displacement. That displacement I can write like this. How can I write? Final displacement minus initial displacement. Can I write like that?
Yes, sir.
Because if you add all the starting to ending, if you add it, that is equal to final position minus initial position, both are same. So in terms of vector quantity, okay, the final displacement minus initial displacement, you can take it like this, by time also, total final time minus initial time, final time minus initial time. So what I can write here? Change in displacement by change in time. Change in displacement by change in time is also called as average velocity. Understand? This formula can be applicable for equal time or unequal time. Both the cases we can apply. So in the case of equal time, unequal time, I can write the formula, okay, in different forms. Okay, now, so what is the average velocity? Average velocity is equal to, simply I can write change in displacement by change in time, or total displacement by total time. In terms of velocity terms, average velocity is equal to, in the case of equal, v1 plus v2 by, that is total time is 2. Here also same way, you are going to take sum of all the velocities by 2. In the case of equal time. In the case of unequal time, again the same formula. In the case of unequal time, that case also we are going to take 2v1 v2 by v1 plus v2. So this is the formula we are using only in the case of bodies which are moving in a single direction only. Which direction?
Single
Single.
letter.
If the bodies are moving in 2 dimension, 3 dimension, then velocity is a vector. So direction changes means automatically average speed method of calculation also changes. Okay. Look at the example for average velocity. A person walking towards east with a speed 20 meter per second. Then after the person turned towards north. Again he traveled for a distance of 30 meter per second with a speed 30 meter per second. What is the average? What is the average velocity? In this case, first towards the east, he taken totally, okay, time is equal to 10 seconds. Second also he taken 10 seconds. Now how to take this one? In this case, this is we are taking as v1 vector. This one we are taking as v2 vector. But both are not in the same direction. So this is the initial point and this is the final point. Right? In this case, to take the average velocity, v average is equal to, okay, same like you can take it, you can use the Pythagoras theorem. Like if you use the Pythagoras theorem, this is the resultant you, that resultant is nothing but sum only, that resultant nothing but summation, this value, and this gives a summation of that. So you can take the sum of that one. But here already speeds are given, not distance. Now if you come across here, initial to final, this is length, yes or no?
Yes, sir.
This is length. Length means distance, it is not the speed. So in this case, we are not taking the triangle formation here directly. So simply we can write v1 plus v2 by t1 plus t. So what is v1 plus v2 in this case? Distance is same or different?
Same.
Same?
No, sir.
No, because time is same means distance will be different. So we can use the average speed this formula. So that means how much value? 20 plus 30 by 10 plus 10. How much? 20. That is equal to 50 by 20. I can take it as 0, 0 get cancelled. That is 2.5 meter per second. That is average velocity of this. You got it what I am saying?
Yes, sir.
Right. This is the way you have to calculate here. So that means how to take the direction of that. What the direction of the means? What direction the vehicle is moving averagely? That is only the final direction. This is only the direction of that vehicle. This is the direction of that final point direction here. All right. So what is the acceleration? Acceleration is most important word. You have to understand that because it is most important concept here. Simply, acceleration we are indicating with the letter A. When a vehicle is moving, first the speed of this one is 0 meter per second. Next the speed changes to 10 meter per second. Next 20 meter per second. So on, like this speed is going to be increased like 100 meter per second. Example, while you are running the bike or vehicles, you can see you have holding a accelerator. As that the accelerator changes, automatically speed of the vehicle also changes. So simply I can say acceleration is a term which depends on speed and velocity. Actually, acceleration is a vector quantity.
Acceleration is a vector, sir.
Yes,
Okay, sir.
acceleration is a vector
As
quantity.
I was about to ask if it is a vector quantity or not, you said that acceleration is a vector quantity.
It is a vector quantity. Acceleration is a vector quantity. That's why we
You
are
place
giving.
an arrow above.
Yes, we place the arrow above. That's why we are explaining that one in terms of velocity. So acceleration is equal to, we can write in terms of rate of change of velocity. That is dv by dt. Velocity by time is called as acceleration. Suppose if you want to calculate acceleration only value without direction, only magnitude I want, that means a bar, if they given, is equal to, then you have to define speed by time. Because speed and velocity both are almost same terms except the direction. If you are calculating the acceleration of a particular vehicle in terms of magnitude and direction, this is the formula to use. Only in terms of magnitude, this is the formula we use. Okay, na? Now,
Yes,
in this
sir.
case, how to calculate here, that is most important. The acceleration is, if you come across a case of example here. So here 0, first 0 meter per second changes to 10. So what is changed here? Velocity changed here. So acceleration we can define like this. It is nothing but change in velocity.
Change in velocity.
Final velocity minus initial velocity by total time. Okay, total time means t2 minus, that is tf minus tf. This is gives the concept of acceleration. In terms of higher level, this we can write as in terms of differential function as dv by dt also. Okay, we can go further relate to that one in the next levels. Okay, so acceleration is equal to change in velocity by change in time. So here acceleration, one of the term which depends on change in velocity, which velocity change. So I can write that one as delta v by t in terms of vector. So which gives the acceleration direction? Always remember, the change in velocity gives the direction of the vector. What direction change is there, that direction the acceleration of the vehicle is there, we have to identify. That is most important. Based on this one, we are going to discuss one concept here. This is the one vehicle initially moving with a speed 10 meter per second, with a speed v1. Then after, take vi initial. Finally, the speed of this one becomes into 30 meter per second. That is v final. In the time of 1 second. The time of 1 second. So what is acceleration? In this case, acceleration is equal to, what is the formula we discussed? V final minus V initial by time. So what is V final value? 30. Initial value 10 by 1. So that is equal to how much? 20. Okay, 20 by 1. Along with that, units of this one is meter per second square. So in this case, our concentration is what? Acceleration value. What you
Second
got?
square.
Meter per second square. How you got the unit? I will explain. Okay, first listen this one. Acceleration, how much you got? 20, right? The 20 value is positive or negative? That is important for us. The 20 value is positive or negative?
Positive.
Yes. I erased all.
Sir.
Yes. Now what I said just, okay, acceleration is equal to nothing but change in velocity, right? V final minus V initial by time. So to explain this one, what I said, example. What is the example? Vehicle is having initial velocity. What is the 10 meter per second? After certain time, what is the speed? Final speed. Final velocity,
30
what?
meters per second.
30 meter per second, we take, right? So in the time of 1 second. So acceleration is nothing but change in velocity. What is the final velocity? 30 minus 10
Minus 10
by 1 is equal to, we got 20 meter per second square. I will tell you the,
second
okay,
square.
yes, I will tell you. Okay, now you got this point first.
Yes, sir.
Now this point,
Absolutely
whatever,
positive.
yes, that, okay, that value you got positive or negative? Positive.
Positive.
Yes, plus 20 plus, okay, that means this change in value 30 minus 10, this value, if it is positive, then acceleration will be always positive. Okay,
Okay, sir.
that is called accelerated body. That is called accelerated body.
Accelerated.
Body.
Okay, sir.
Accelerated body we are called. Okay, suppose another example I will take. A vehicle is moving already with a speed 50 meter per second, and he is applying the brakes to stop it. The speed of that one becomes equal to, okay, 20 meter per second after 1 second. Now what is the acceleration of this one? Acceleration is equal to final velocity minus initial velocity
Initial velocity,
by time.
total time.
Okay, total time. Now in this case, what is final velocity?
20 meters per second.
20 minus initial is 50
50
by 1.
by
So this value how much you'll get?
minus 30.
Minus 30 meter per second. In this case, our concentration is here minus. What that minus? This difference gives the negative minus. So if the difference in the velocity is negative, then acceleration is
Acceleration
also
is
negative.
negative.
This negative acceleration is called as deceleration we are calling, or retardation we are calling.
Deacceleration.
Deceleration, or also called as retardation. 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 Retarding. Okay,
Okay, sir.
that is called retardation. RETARDATION. Retardation.
Okay, sir.
Right? So what are the main points here? If the change in velocity is positive, acceleration is positive. Change in velocity negative, acceleration is negative. Change in velocity is 0, acceleration is 0. Okay. Suppose if the change in velocity is constant. Constant means same value all the time. In this case, acceleration also constant. If the acceleration is constant, that is called uniform acceleration. What is called? Uniform acceleration. What is the basic formula for acceleration? Acceleration basic formula is velocity by time.
Right.
So this is, I can write as 1 by t into velocity. What is velocity formula? Distance by time. Velocity means displacement by time. Acceleration equal to velocity by time. Velocity nothing but displacement by time. Yes or no? So
Yes, sir.
acceleration is equal to what I can write? Displacement by time. How many times are there?
T
1,
squared.
2. That means t square. So distance we are measuring in terms of meters. Time we are measuring in terms of seconds. Second power how much? 2. So it is called
X
second square.
squared.
So that's why the square will come in the acceleration units. Okay.
Sir.
What we are learning in these kinematic equations? In the kinematic equations, we have 4 equations. First equation, V is equal to U plus A. Second equation, V square minus U square is equal to AS. Third equation, S equal to UT plus half AT square. And fourth equation, Sn is equal to U plus A by 2 into 2n minus 1. These are the 4 equations we have in the kinematics. First, you have to understand this, when you can use these equations. These equations are related to only one-dimensional motion equations, 1D motion. And the body is moving in a straight line, either only along x-axis, or only along y-axis, or only along z-axis. Single axis direction, only we can apply this equations 4. Second, is these equations can be applicable for any bodies means? No, we cannot apply for all the bodies. We can apply these equations only for the bodies which are moving with this, moving with acceleration. Understanding? Moving with acceleration. Which acceleration? That is also important here. That is uniform acceleration. Which acceleration?
Uniform.
So that means kinematic equations are applicable only for uniformly accelerated bodies only. A is equal to constant, called as uniform. Kinematic equations applicable for uniformly accelerating bodies only. If it is non-uniform, we are not going to apply these equations. We are going to use higher level method, that is called integration and differentiation. That will come in the mains and advanced level in the intermediate. Okay.
Okay, sir.
So Within that, you have to learn the practice of max to understand the non-uniform accelerated ones. So in this case, one more point is there, and these equations are applicable by basing on vector or scalar. You can use this one actually. These are all vector based. We can able to explain. Final velocity, initial velocity, acceleration time. This is also vector based. This is also vector
What is
based.
useless?
All are vectors. Okay, vector based you can solve it. Scalar based also we can able to solve.
What is useless?
Yes.
What is useless?
What is u? Already we told no. What is u? What is u?
Use
U is called initial velocity. Starting kinematics.
With I. So
U is called initial velocity. U is called initial velocity.
F is final velocity. No.
U is called initial velocity. V is called final velocity. Okay.
Okay, sir.
A car is moving with initial velocity. After some time, the velocity will become equal to v. Okay, in the time of t. The time of t. So in this case, what is changed? What is changed?
The distance.
Velocity changed. Initial velocity u changes to final velocity v. So when velocity changes, what happens? When velocity changes, what happens to the condition of the body? When velocity changes, that body is said to be accelerating. What you can say?
Accelerate.
Accelerating. How can you say accelerating? Because velocity is changing.
Change in motion.
Yes. So that means I can say here it is accelerating. Okay. Now write the formula for acceleration. What is the formula for acceleration? A is equal to
A by T.
V. Two velocities
By
are there. Two velocities are there.
past.
Final velocity minus initial velocity by time.
Distance.
Now what is final velocity? V. What is initial velocity?
U.
U by t. Now cross multiply this one. This one cross multiply. What you'll get? A into t is equal to v minus u. Can I write?
Yes, sir.
Right. So AT is equal to v minus u means what is v is equal to this minus 1, make it to this side. What it becomes?
Plus.
Plus. That means u plus AT. What is the first equation? Look at it.
Okay, sir.
So v is equal to u plus AT. Like this, every equation is basing on the condition. Okay, we can able to solve. Listen carefully. These four kinematic equations when you have to use. First equation, look at here. What is not present in the question? When vehicle, look at this one, right side. Initial velocity u changes to v in the time of t. Is the vehicle will be, is the vehicle will be same place or different place?
Different.
Different. So can I say it is travel some distance?
Yes, sir.
That displacement is called as s. So we have a displacement, we have velocity, initial velocity, final velocity, acceleration time. So
This
in the
distance is
yes, first equation, if you see, if the distance, the displacement is not given in the question,
yes, sir.
displacement is not given in the question, you have to use this first equation. Blindly remember.
Okay,
In the
sir.
question problem, if the displacement not given, first equation. Second equation when you have to use, this equation when you have to use. What is not there in the second equation?
Tie.
Time, right, correct. Time is not there, right? In the
Yes,
question, if
sir.
the time is not given, you have to use second kinematic equation. Third one. What is not there in the third equation?
Velocity.
Which velocity? There are two velocities are there.
Yeah.
There are two velocities are there. Initial velocity, final velocity. Which velocity is not given?
5.
Final velocity is not given. Okay, V is not given. U is there, S is there, A is there, T is there. V is not there. So then you have to use this. Now last equation when you have to use. The last equation we are using, that means a car is covered some distance from time t equal to 0 to t is equal to up to 10 seconds. 10 seconds means I can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this 1, 2, 3, okay, 9, 10. Right? So if you are
Okay.
calculating the distance covered by the body in a complete 10 seconds, complete, starting 0 to 10, complete 10 seconds, then you have to use this equation S equal to ut plus half a t square equation you have to use. అర్థమైందా? Understand?
Half A.
Half a t square.
అర్థం కాలేదు సార్.
Half a t square formula just I've written now just before.
No, not that one, sir. What you were explaining.
The question will be asked like this: what is the distance traveled in the third second? Which second? Third second. What is the distance traveled in the third second? Third second means what? This is called as third second. 0 to 1 called as first second. 1 to 2 called as second second. 2 to 3 is called as third second.
Third second.
Understanding? So,
Yes,
and this
sir.
one is called as 10th second. So, the distance traveled by the body in this time, 2 to 3 seconds, is called as, okay, 1 second distance. That 1 second distance formula you are using, Sn equal to u plus a by 2 into 2n minus 1. This formula you are going to use. అర్థమైందా? What is n here? N is called nth second. If you are calculating for first second, then n value becomes 1. If you are calculating for third second, n value becomes 3. If you are calculating for the 10th second, n value becomes 10. If you are calculating for n seconds, n value becomes n. Like this, you have to apply the condition. And this 1 second, third second, 10 second, n second, that is all only 1 second time. Understanding? Only 1 second distance. 1 second. This is the time, this is the distance for only 1 second. This is the distance for complete time. So look at the one question, how to use it. A car starting from rest. A car starting from rest travels for a time of 10 seconds. Acquires the final velocity of 20 meter per second. Acquires the final velocity of 20 meter per second. Calculate the acceleration of the car. Calculate the acceleration of the car. So here question you need to understand what is given. Eppudayina sare while you are solving any problem in the physics, first write down the data what is given first. What is given? A car starting from
Initial
rest. Rest means
rest.
initial velocity is 0.
Okay, sir.
And how much time it is traveling? 10 seconds. Write it down. What is the final speed when reaches to the end point?
20 meters per
20
second.
meter per second. So what the question they're asking? Acceleration. This is the way you are to indicate.
Now acceleration is equal to.
Now look at the formula related to which, okay, you have to take the formula here. So what is not given? What is not given? Distance not given. So what equation you have to use? V is equal to u plus 80.
Okay, sir.
Now apply the values. What is V? 20. What is U?
Just 80, sir.
Yeah, just 80, right? Yes or no? 0 plus 80. What is A? They're asking to find. What is T? 10 seconds. How much you'll get? 10A is equal
100
to
divided by 10. 2 is equals to
0, 0 cancel. A is
the
equal to
same.
2 meter per second square. Yes or no?
Yes, sir.
This is a basic model. Next problem. A car is starting from rest, moving with a uniform acceleration 20 meter per second. After time t is equal to 10 seconds. What is the distance traveled by the car? First question. What is the velocity of the car? Second question. Question is, a car is starting from rest, moving with the uniform acceleration 20 meter per second, and after 10 seconds, what is the distance covered by the car? What is the speed of the car?
Mm.
To find the first question, what is
Use
distance covered?
use 80.
Yes. First, which formula you have to use? First, write
That's
the
V is equals to U plus 80.
V is equal to
U plus 80.
U plus 80. Distance is not given, question mark, right? Distance is not given means V plus V is equal to U plus 80. How can you use? There is no distance term at all.
Yes, sir.
So first you write it data what is given. What is given? A is given 2 meter per second. 20 meter per second. Second,
U
time
is
is
given
given. Yes, U is also given. How much U?
0.
0 meter per second. Time units is seconds. Next, what they're asking? Yes, yes, they are asking. So question they mentioned as. So what is the kinematic equation related to this one? SUAT.
U plus 1 by 2 80 square.
Yes, that equation you have to use. S equal to, okay, S equal to UT plus half 80 square. This equation you have to use. Apply here. What is this value they are asking to find? U value how much? 0. 0 into this one, 0. 0 plus half into, what is A? Acceleration given 20 into time. How much time is given? After 10 seconds they are asking 10, but we have a square is there, 10 square. So if you solve this one to how many times? 10 times.
10 times.
And this is equal to 10 into 100. Yes or no? 10 square means 100. That is
Mm.
equal to 1000
Thousand.
meters. Nothing but 1 kilometer. Similarly, second question. Second question, what is the given? A is given, T is given, U is given, and they are asking V is equal to how much? What is the kinematic formula related to these four terms? Which formula? Okay, V is equal to U plus 80. So that is the important you need to understand. If you understand that one to identify the exact formula, it will take less time and you will be okay more ranking towards a more ranking method, right? Otherwise, you will take long time and you will do the less problems and you will get the less marks also. Okay, so we require V. What is U value? 0 plus A value how much? That is 20 into time 10. So how much you'll get? That is 200 meter per second. So the velocity after 10 seconds is 200
200.
meter per second. Next one, you only do it. A car is starting from rest. after time t equal to 5 seconds.
Sir, I did not hear you at 5:12.
Yes, what you're
Can
saying?
you repeat the question, sir? I did not hear you.
A car is starting from rest.
Hmm?
A car
Yeah.
is starting from rest.
Okay, sir.
After 5 seconds, its velocity is 30 meter per second. Velocity is 30 meter per second. What is the velocity of the car? What is the velocity of the car after time t is equal to 20 seconds? What is the velocity of the car after time t is equal to 20 seconds?
Simply,
First write it. First write it. What is given? Initial velocity is 0.
hmm.
Right? Next,
Yes, sir.
time t equal to 5 seconds. Final velocity is given how much? 30 meter per second at that moment. That is, you take it as v1. Okay, take it as t1, v1. Next, second part, what is given? At time t equal to 20 seconds means t2 అని తీసుకో 20
టూ
seconds.
పార్ట్స్ తీసుకోవాలా సార్ దీన్ని ఇప్పుడు
అంతే కదా, 2 పార్ట్స్ కదా. t2 t2లో స్పీడ్ ఎంత?
సబ్స్టిట్యూట్ టూ పార్ట్స్ అనే చేయాలి సార్.
అట్లా కాదు, ఇప్పుడు మనం అండర్స్టాండ్ చేసుకోవాల్సింది ఏంటంటే మనకి క్వశ్చన్ ఎక్కడ ఉంది? వేర్ ఇస్ ద క్వశ్చన్? ఫస్ట్ డాటానా సెకండ్ డాటా?
సెకండ్.
This is second data, right? So in this case you need v, you have a 20, right? So ante this v ana manaku telusu, we know that this final velocity and you know that this velocity. Can I take this velocity as initial velocity for this one? U is equal to 30.
Yes, sir.
Yes, so
Yes, sir.
you have a u for second. This is first part, this is second part. This is first part, this is second part. Okay, equation. First part manaki second part lo question. We have a question in the second part. In that second part, we know the initial velocity 30. We are okay. They are asking to find the final velocity v, and the time is given 20. But 20 from where it is given? That is important. From where it is given? Time t equal to 0. Starting from. Okay,
Zero.
so yes, if you taken from 30 to here, from this point to this point, if you taken, what is the time here? Time is 5 seconds, the time is 20.
20 seconds.
Now what is the change in time in between?
15 seconds.
15 seconds. This is the time you have to take while calculating. So delta t is equal to 15 seconds.
Okay, change.
Now this delta t is nothing but t only, but what is given? U is given, v they are asking time. But if you want to apply any kinematic equation, here we are not having acceleration. Yes or no?
Yes, sir.
Every equation,
No
every,
acceleration.
yes, every kinematic equation contains an acceleration. So there is no acceleration here. So that acceleration which is not given, okay, which is not given, that you have to calculate from here. First condition. How to calculate? Or otherwise second also you can calculate. Second also, okay, first, okay, they are asking v, no, right? Here two unknowns are there, a and v, two unknowns. So calculate the acceleration from the first. What is first? U is given, v is given, time is also given 5 seconds. A they are asking, a is equal to how much? Because what acceleration the vehicle is moving here, with the same acceleration here also it moves. You understand this point? What is the acceleration here? Same acceleration in the first part, same acceleration in the second part. So acceleration must be constant. Then only we can apply kinematic equation. So acceleration remain throughout the journey, it is same, means a is equal to this. So from the first part, this part, you have to calculate v. Sorry, a. So what is the equation? V is equal to u plus at we have to use. In the place of v, what we have? v1. Okay. So now calculate this one. What is v1 value? 30. Yes or no? v1 is 30. What is u value? 0. Plus what is a value? They are asking to find. What is t value? Time is equal to 5 seconds. So from this what I can write? Phi a is equal to 30. So a is equal to how much? 30 by
6.
5. That is equal to 6
6.
meter per second square. So you got the acceleration.
Yes, sir.
Now use this acceleration in the second part. So second part, what is the equation? What is given? What are the things you know that? U. U is how much? 30.
13.
V, they're asking to find. A is how much? Just we done. 6
6
meter
meters.
per second square.
Second square.
What is given? Time. How much time difference? 15 seconds. That is important here. Because they are calculating from 30 to V. Suppose, no sir, I don't want to take from 30, I want to calculate from starting. Starting onwards also you can calculate. If you want to calculate from starting, then you take that U is equal to 0. Okay? If you want to calculate from starting, take U is equal to 0. In that case, time how much you have to take? Time is equal to you take 20, not 15. అర్థమవుతుందా? If you are calculating from, see, look at here. If you are calculating from here to here, then U is 30. If you are calculating from here to here, U is 0. If you are calculating from here to here, 30 to this, what is time? Time is how much? 15 seconds. If you are calculating from here to here, what is the time?
0.
20 seconds.
Time is 20 seconds.
So, which is convenient? Both the ways you can do it. That your wish. So, మనం రెండు చేద్దాం, రెండు చేసి వెరిఫై చేద్దాం. If you come across this one, so what is the formula? VUAT. V is equal to U plus AT. First kinematic equation you have to use.
Okay.
V value they are asking. What is U? 30 plus what is A? 6
According to second one, sir.
according to second. This one. Okay. So how much you will get? V is equal to 30 plus 15, 6 are
90.
90 total. Okay.
Okay, sir.
Right. Similarly, for the second part, if you want to calculate from starting, use the same equation. V is equal to U plus A. What is V? They're asking to find. What is U? 0. What is A? 6.
6 meters.
6 into time how much? 20. How much you got? 6 into 20. 120. Same you got, different. You got same or different?
Yes, sir.
Same.